Okay, in today's lessons, we'll be distinguishing between proportional and non-proportional situations. Let's go over a couple of definitions here real quick. Let's remember that the slope is a steepness of a line. So rate of change in y vertical compared to change in x horizontal, or rise over run, or the change in y values over the change in x values, or of course our formula y2 minus y1 over x2 minus x1. This denotes our m and y equals mx plus b. Of course, we got our y-intercept as well. It is the y-coordinate of a point at which the relationship crosses the y-axis, meaning the x-coordinate is equal to 0. Denoted as b and y equals mx plus b, and the order pair 0, b. Once again, y-intercept is where x equals 0, and of course we can have a different number every single time. It just depends. A linear relationship. A relationship with a constant rate of change represented by a graph that forms a straight line. One quantity is dependent on the other. Two quantities may be directly proportional to each other. Can be classified as a positive or negative relationship. Can be expressed as a pair of values that can be graphed as ordered pairs. And graph the ordered pairs match the relationship will form a line. Okay, a function. A function is a relation in which each element of the input is paired exactly with one element of the output y. We have our linear proportional functions. Once again, it's linear as defined in the sentence. If it's proportional, it passes through the point 0, 0. So when x is 0, y is also 0. It's represented by y equals kx. The constant of proportionality, or the k value, would be equal to y over x. And it represents, it's b equals 0 and y equals mx plus b. Then k is equal to the slope, m. Once again, it has to go through the origin, so it has to have the form y equals kx, or it can be in the form y equals mx plus b, but b has to be equal to 0. A linear non-proportional function, once again, is linear. It does not pass to the origin, 0, 0. It's represented by y equals mx plus b, where b is not equal to 0. And of course, constant slope is represented by what we've established up above. Alright, so it is pretty much kind of easy to see if something is proportional or non-proportional. It's pretty much if it goes to the origin, especially if we can find their functions. Now let's go and skip through this and look at some sample problems. This lesson should not take too long, but let's go to the first one. Oh, a couple more. Almost there. Okay. This asks, which equation does not represent a proportional relationship between x and y? Well, it's pretty easy to establish which one's not proportional, because once again, it will have the form y equals kx, or even y equals mx plus b. But once again, the b would have to equal 0 if it were proportional, which then pretty much would say that we have y equals mx form. Okay, well, let's look at answer choice A. A is y equals 0.75x. Well, since we don't have a b, it is assumed as 0, so it is plus 0. So therefore, he is proportional. And of course, we're looking for one that's not proportional, so it cannot be A. Y equals 4x. Well, once again, our b is 0, so he is proportional. Y equals 1.5x. Once again, our b is 0. And then D, y equals 2x plus 3. See, our b is not equal to 0. Therefore, this guy is our non-proportional. D is the answer. He does not represent a proportional relationship. Pretty easy. Alright, on this one, on a recent road trip, Judith recorded travel information as shown in the table below. Time versus distance. Determine if the relationship between time and miles traveled represents a proportional or non-proportional relationship. Justify your answer. There is a couple of routes we could go to solve this. I'm going to give you two. We could find the equation, and that is one route to go. I'm not going to do, well, I am going to do that, but I'm going to do it with the calculator. But I'm also going to show you that if the constant of proportionality is the same, we know it's proportional. What I mean by that is we take our change in y over our change in x. So we go up by 10, so plus 10. And here we go up by plus 12. Once again, y over x, and in this case we get 10 over 12. And we can simplify the fraction if we need to, but for right now, I'm not going to if I don't need to. Once again, going from 20 to 30, I go up by plus 10. 24 to 36, I go up by plus 12. So once again, we get the same thing, 10 over 12. And 30 to 40 is plus 10. And 36 to 48 is plus 12. Okay, well, once again, 10 over 12. So our constant of proportionality is the same, which does tell me that this is a proportional relationship. You could also look back and say, well, if I go backwards, I would actually go minus 10 or go to 0. And here I go backwards. And of course, we go to 0 as well. Go back by 12. And here, therefore, we have the point 0, comma 0. So when x is 0, y is 0. It's another way to determine that this is a proportional relationship. Actually, from here, I can easily tell you that the equation is y equals, we'll simplify this guy down, 10 over 12, and we get 5 over 6, x, our constant proportionality. And of course, we don't have a b since our b is 0, so there would be our equation. Once again, you can tell it's proportional. One last way we can determine, I'll show you with the electronic way. Let me take this over real quick. Let's grab this table real quick, okay? Alrighty. Let's use our calculator real quick. And in order to find the function, we know it's linear. We're going to hit the stat button. Stat. We're going to edit a table, so go ahead and hit enter. We need to clear these tables out, so usually I highlight the top, press clear, enter, clears it all out for me. Scroll over, let's clear out that L1 list, so clear, enter. Okay. Now we can plug in our points. You can use all of them, or you can just use two since it says linear. I'm going to go ahead and use them all. Once again, it doesn't matter. You're going to get the same thing. 36, 48, enter. Scroll over to my L2 list, put my Y values in. 10, enter. 20, enter. 30, enter. 40, enter. Okay, now that we have our table set up, let's go ahead and hit the stat button again. Stat. This time we want to do a calculation, so we're going to scroll over to calculate by clicking this right arrow. And then we want to choose the line reg option since we're looking for a linear equation. You can either just scroll down to it and press enter, or you can even hit 4. I'm going to go and scroll down, hit enter. And now I'm going to ask it to calculate. And right then and there you get your function, and we see that the b is equal to 0. So once again, if the b is 0, we do have a proportional relationship. If you're ever trying to figure out how to make that a, that's our slope in this case, and this will be a lesson later, and you'll do this over and over again. But if you had to make that guy into a fraction, because we don't like decimals like that, we can just go 0.8, and I say just repeatedly hit the 3 until your calculator gets the point. Easy. There's a couple ways. We can just enter and hit math button over here, right below the alpha button, and hit enter, and it turns that number into a fraction. So therefore, that is the same thing that we got earlier. When I figured this guy out for you guys, we did get y equals 5 over 6x. Once again, this is proportional. Determine the relationship between time and miles traveled represents a proportional. It is proportional. And justify your response. Well, to justify, we'll just say because b is equal to 0, it is a proportional relationship, or because our table goes to the origin, or we do have the point 0, comma 0. Okay. Moving on. After selling 500 electronic devices online, Theodore decided to open a store to sell electronic devices to in-store customers as well as online customers. The graph below shows Theodore's online and in-store electronic device sales according to the number of months since opening the store. Okay. Well, months since opening the store represents our X values. Now we're electronic devices. Okay, which statement is true about the relationship of the data displayed in the graph? Alright, I can't really shrink this down, but let's look at the answer choices. It says the data in the graph represents a linear proportional relationship. B says the data in the graph represents a linear proportional relationship. C, the data represents a linear non-proportional relationship. Or D, the data represents a linear non-proportional relationship. Okay. Well, if it were proportional, it would go through this point right here, 0, 0, it would go through the origin. We see that it doesn't. It actually has a y-intercept of 500. So therefore, we know that it is non-proportional. So A and B are eliminated. All right, let's finish off C and D and see what they want. It says, because the data forms a straight line with a constant rate of change of 500 units per month, and the graph does not include the order pair 0, 0, which is correct. The data represents a linear non-proportional relationship because the data forms a straight line with a constant rate of change of 750 units per month, and the graph does not include the order pair 0, 0. So the difference between C and D is the constant rate of change, or our slope. Let's go back to our graph and see if we can figure out what our slope is, or our constant rate of change. It looks like we go from this point 0, 500. That's one of our points. And then we see this other point at 1. Okay, so at 1 month, it's 1,250. Okay. We could do the y2 minus y1 over x2 minus x1. I think many of y'all can already see this, that we're going to go up from 500 to 1,250. It goes up 750 units per the 1 month. So we can see that the constant rate of change is 750. To double check that, let's just say if we went to 2 months and we add another 750, we should be at 2,000. Look at that, 2 months, we do have 2,000 units. So our constant rate of change is 750. Okay. So that would mean that the answer choice that would be correct in this case would be D. D is good for us. Okay, last question. Which relationship is an example of a proportional relationship? Okay, we want proportional. So let's see. A rental car costs 59 cents per day. Or sorry, $59. So $59, so like our total cost. Let's call it Y. $59 per day plus 0.08 or 8 cents per mile. So once again, you can see that our B is not equal to 0, so he is not proportional. A gym membership has a $45 registration fee. Okay, so the total cost would be $45 for the registration fee, and sometimes represented with a plus $25 per month, $25 for every month. You can call it YX, whatever you want. Once again, that just looks a little bit different than our normal form of MX plus B, but I can go ahead and switch that around to make it look like that. And once again, you can see that our B is not equal to 0, because just to get in, we have to pay money to begin with. So we don't have 0 months, $0. So once again, he is not a proportional relationship. Okay. Looking at answer choice C, it says a cell phone bill is $30. Okay, well, total cost of a cell phone bill is $30 plus 10 cents for each call over 100 minutes. So after 100 minutes, our equation would be, let's call it X per minute. Once again, you would have to write this as such that X is greater than or equal to 100, just to represent that after 100 minutes this equation starts going through, otherwise it's just $30. So we do have a starting point once again at $30. So he is not proportional. And lastly, Samuel earns $20 for each lawn he mows. Well, Samuel's total amount that he gets is $20 per every lawn. writing the equation, we can see that he gets $0 if he doesn't mow any lawns. So we do have the 0.00. We do go through the origin. Therefore, this guy is a proportional relationship. Okay. Well, that is today's lesson. I hope you learned something. And thank you.